let us crack GATE ME. Unacademy is announcing Brahmastra Plus batch and Mission batches for GATE and ESE 2024 and 25. Now, save up to 50% off on mechanical and chemical subscriptions with 4 months free extension. Now, hurry, offer is valid till 28th October. Offer is valid till 28th October. Save up to 50% off on your subscriptions with 4 months free extension. Subscribe now. Unlock 25% offer. Flat 25% off on all subscriptions plus up to 4 months free extension. Save up to 50% on your subscriptions. Save up to 50% on your subscriptions with extra 3 months free. Flat 25% off on all subscriptions and 4 months free extension. 10% price drop on 12 plus months and above plus and iconic subscriptions. Extension offers 4 plus 1, 6 plus 2, 12 plus 3 and 24 plus 4 on plus and iconic subscriptions. Unacademy is announcing Brahmastra Plus batch for GATE 2024. Batch commences from October 31st. Unacademy is announcing Mission 1 batch for GATE and ESE 2025. Batch commences from October 31st. Get started with no cost EMI and 0% interest on the loan. Approval in 2 hours, minimal paperwork, flexible tenures. Unacademy is congratulating GATE 2023 top rankers. Today I would like to discuss the concept on diagonalization. Concept of diagonalization. What is diagonalization? When we can say that a matrix is diagonalizable. A square matrix A is said to be diagonalizable A square matrix A is said to be diagonalizable if there exists a non-singular matrix P such that P inverse AP equal to diagonal matrix D. P inverse AP equal to diagonal matrix D. Sir, how to identify that non-singular matrix P? Simple. A square matrix A is said to be diagonalizable when algebraic multiplicity and geometric multiplicity of each eigenvalue coincides. If algebraic multiplicity and geometric multiplicity of each eigenvalue coincides, we can conclude that the matrix is diagonalizable. What is the process of diagonalization? Working rule. Suppose matrix A is 3 cross 3. Find eigenvalues find eigenvalues find find the corresponding eigenvectors. Suppose eigenvalues are lambda 1, lambda 2, lambda 3. Corresponding eigenvectors are x1, x2, x3. Then write model matrix P. Model matrix is collection of eigenvectors. Calculate P inverse. Calculate P inverse AP that gives diagonal matrix D. If you calculate P inverse AP which gives diagonal matrix D, that is the procedure to calculate whether the matrix is diagonalizable or not. Now, for example, matrix A is 4, 2, 2, 4. First you have to calculate eigenvalues. The characteristic equation is determinant of A minus lambda equal to 0. Four minus lambda whole square minus 4 equal to 0. 16 minus 8 lambda plus lambda square minus 4 equal to 0. That implies lambda square minus 8 lambda plus 12 equal to 0. Lambda minus 2 into lambda minus 6 equal to 0. Lambda equal to 2, lambda equal to 6. The eigenvalues are 2 and 6. Corresponding to eigenvalue lambda equal to 2. Consider A minus 2i of x equal to 0. Put lambda equal to 2. Four minus 2, 2, 2, 2, 2. Now R2 minus R1, you'll get 2200. Rank is 1. Number of variables 2. Free variables 1. The equation is 2x1 plus 2x2 equal to 0. 2x1 plus 2k equal to 0. x1 equal to minus k. Therefore, x1, x2 is minus kk. Take k common. Minus 1, 1. The eigenvector is minus 1, 1. So, one of the eigenvector is minus 1, 1. Good evening, Ariom Yadav. Lambda equal to 6. Consider a minus 6i of x equal to 0. Now R2 plus R1. Rank is 1. Number of variables 2. Free variables 2 minus 1, 1. The equation is minus 2x1 plus 2x2 equal to 0. x1 equal to k. Therefore, x1, x2 is kk. Take k common, k into 1, 1. The eigenvector is 1, 1. Model matrix P is x1, x2. Minus 1, 1, 1, 1. Now, determinant value of P is minus 1, that is minus 2. Adjoint of P is D minus B minus C A. Now, P inverse AP one by minus 2 of 1 minus 1 minus 1 minus 1 A 4224 P minus 1 1 1 1 multiply these two. Minus 4 plus 2 minus 2. 4 plus 2 6. Minus 2 plus 4 plus 2. 2 plus 4 6. One by minus 2 of minus 2 minus 2 minus 4 6 minus 6 0 plus 2 minus 2 0 minus 6 minus 6 minus 12 minus 4 by minus 2 is 2 0 0 minus 12 by minus 2 is 6 2 6, which is nothing but diagonal matrix D, which is clearly in the form of a diagonal matrix, because where leading diagonal elements are nothing but eigenvalues. This process is known as diagonalization. Understood? Suppose your matrix is 3 cross 3. Zero one minus 2, 0 1 0, 1 minus 1 3. That is the given matrix. First you have to find characteristic equation is determinant of A minus lambda equal to 0. Determinant of 0 minus lambda 1 minus 2 0 1 minus lambda 0 1 minus 1 3 minus lambda equal to 0. That implies if we expand determinant by using middle row 1 minus lambda into minus lambda into 3 minus lambda minus 3 lambda plus lambda square plus 2 equal to 0. Lambda square minus 3 lambda plus 2 plus 3 lambda square minus lambda cube minus 2 lambda equal to 0. Minus lambda cube plus 4 lambda square minus 5 lambda plus 2 equal to 0. Lambda cube minus 4 lambda square plus 5 lambda minus 2 equal to 0. That can be written as unnecessarily expansion. Directly we can write lambda minus 1 into lambda minus 1 into lambda minus 2 equal to 0. Lambda equal to 1 comma 1 comma 2. From this you can able to find out lambda equal to 1. Here lambda minus 1 into lambda minus 2. That implies lambda equal to 1 comma 1 comma 2. Algebraic multiplicity of eigenvalue 1 is 2. Eigenvalue 1 is repeated 2 times. Algebraic multiplicity of eigenvalue 2 is 1, because eigenvalue 2 is appeared only once. Now First we have to find out eigenvector corresponding to eigenvalue 2. Consider a minus 2i of x equal to 0 put lambda equal to 2 in a minus lambda I. Minus 2, 1 minus 2. Zero minus 1, 0. One minus 1, 1. Now, select any two non-zero rows. Select any two non-zero rows. Right, middle, last, first, middle. Apply AD minus BC technique. That implies x1 by minus 2, x2 by 0, x3 by 2. After cancellation, minus 1, 0, 1 is the eigenvector. Minus 1, 0, 1 is eigenvector corresponding to eigenvalue 2. Therefore, geometric multiplicity of eigenvalue 2 is 1. Here, geometric multiplicity of eigenvalue 2 is 1. Algebraic multiplicity of eigenvalue 2 is 1. GM and AM of eigenvalue 2 coincides. Now, what about eigenvalue 1? Corresponding to lambda equal to 1. Consider a minus 1i of x equal to 0. Put lambda equal to 1 in a minus lambda I. Minus 1, 1 minus 2. Minus 1, 1 minus 2. 0, 0, 0. 1 minus 1, 2. R3 plus R1 we get rank is 1. Number of variables 3. Free variables equal to 2. The equation is minus x1 plus x2 minus 2x3. Let us take Otherwise, do one thing. Let us take x2 is k, x3 is t, x1 equal to k minus 2t. Therefore, k minus 2t, k, t. K times of 110, t times of minus 201, the eigenvectors are 110 minus 201. Now, model matrix P is x1, x2, x3 minus 101 minus 101 110 minus 201. Determinant value of P is finally 1. Now we have to find out adjoint of P. To calculate adjoint of P, we have one technique. Middle last, first middle. From middle column, middle element, write the elements clockwise. 101, 01 minus 2, 01 minus 1, 101. Okay, repeat first column once again. Adjoint of P is 1 minus 0, 1. 0 minus 1, minus 1. 0 plus 2, 2. 0 minus 0, 0. Minus 1 plus 2 plus 1. 0 minus 0, 0. 0 minus 1 minus 1. 1 minus 0, 1. Minus 1 minus 0 minus 1. Now, P inverse AP. One minus 1, 2. 0, 1, 0. Minus 1, 1, minus 1. Minus 1, 0, 1. 1, 1, 0. Minus 2, 0, 1. Sorry, this is P. We have to write AP na. Here I have to write A. P inverse AP. What is matrix A? 0 1 minus 2 0 1 0. Third row 1 minus 1 3. Now multiply 1 minus 1 2 multiplied with, first you multiply these two, will get 0 0 2 minus 2 4 0 0 0. Next 0 plus 1 plus 0 1 0 0 0 0. Next 0 0 minus 1. Next 1, because minus 1 plus 1 plus 1. Finally 1. 2 plus 0 minus 3 minus 1. Multiplying these two, we will get minus 2 plus 0 plus 4 plus 2, 0 0 0 plus 0 plus 0 0, 0 plus 1 plus 0 1, 0 plus 0 plus 0 0, minus 1 into minus 1 plus 1 plus 0 minus 1 0, minus 1 plus 1 0 0, 2 plus 0 minus 1 1, 2 1 1, 2 1 1 are leading diagonal elements. Whatever eigenvalues you have, finally you got same eigenvalues in the leading diagonal. Understood? So it is diagonalizable. Why? Because algebraic multiplicity of eigenvalue 1 is 2. Eigenvalue 1 is repeated 2 times. Corresponding to eigenvalue 1, you have 2 independent eigenvectors. So geometric multiplicity of eigenvalue 1 is 2. Algebraic multiplicity of eigenvalue 1 is 2. Geometric multiplicity of eigenvalue 1 is 2. So AM and GM of each eigenvalue coincides. Whenever AM and GM of each eigenvalue coincides, we can conclude that the matrix is diagonalizable. Understood? Next problem. Observe. Now the characteristic equation is determinant of A minus lambda equal to 0. Two minus lambda whole cube equal to 0. Therefore, lambda equal to 2 comma 2 comma 2. So we can conclude that the algebraic multiplicity of eigenvalue 2 is 3. Eigenvalue 2 is appeared 3 times. Now, what about geometric multiplicity? Consider A minus 2i of x equal to 0. rank is 0. Number of variables equal to 3. So free variables equal to 3 minus 0, 3. Let us take x1 is k1, x2 is k2, x3 is k3. Therefore, x1, x2, x3 is k1, k2, k3. k1 into 1, 0, 0 plus k2 into 0, 1, 0 plus k3 into 0, 0, 1. The eigenvectors are 0, 1, 0, 1, 0, 0 and 0, 0, 1. 3 independent eigenvectors. Therefore, geometric multiplicity of eigenvalue 2 is 3. Now, modal matrix P is 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, P inverse is also 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, P inverse AP 1, 0, 0, 0, 1, 0, 0, 0, 1 multiplied with 2, 0, 0, 0, 2, 0, 0, 0, 2 multiplied with P is 1, 0, 0, 0, 1, 0, 0, 0, 1. Final result is 2, 0, 0, 0, 2, 0, 0, 0, 2. It is diagonalizable or not? Clearly, the leading diagonal elements are nothing but eigenvalues. It is diagonalizable. Understood? The matrix is diagonalizable. The eigenvalues are nothing but leading diagonal elements of this diagonal matrix D. Next problem. First we have to write characteristic equation. Determinant of a minus lambda equal to 0. That implies 1 minus lambda whole cube equal to 0. Lambda equal to 1 comma 1 comma 1. The algebraic multiplicity of eigenvalue 1 is 3. Eigenvalue 1 is repeated 3 times. Next. Corresponding to lambda equal to 1. Consider a minus 1i of x equal to 0. Put lambda equal to 1, 0, 1, 1, 0, 0, 1. Rank is 2. Number of variables 3. free variable equal to 1. See, eigenvalue 1 is repeated 3 times. Eigenvalue 1 is repeated 3 times. But how many independent eigenvectors you have? The equations are x2 plus x3 equal to 0, x3 equal to 0. From 1 and 2, x2 0, x3 0. Let us take x1 equal to k, x1, x2, x3 is k 0 0, k times of 1 0 0, geometric multiplicity of eigenvalue 1 is 1. AM is not equal to GM corresponding to eigenvalue 1. Therefore, the matrix is not diagonalizable. The matrix is not diagonalizable. The matrix is not diagonalizable. For example, matrix is 1 1 0 1. The characteristic equation is determinant of a minus lambda equal to 0. 1 minus lambda 1, 0 into 1 minus lambda. Now, 1 minus lambda whole square equal to 0, lambda equal to 1 comma 1. Algebraic multiplicity of eigenvalue 1 is 2. Algebraic multiplicity of eigenvalue 1 is 2. Corresponding to lambda equal to 1. Consider a minus 1i of x equal to 0. Put lambda equal to 1, 0, 1, 0, 0. Rank is 1. Number of variables 2. Free variables equal to 1. The equation is x2 equal to 0. Let us take x1 equal to k. Therefore, x1, x2 is k0, k into 1, 0. The eigenvector is 1, 0. Geometric multiplicity of eigenvalue 1 is 1. Geometric multiplicity of eigenvalue 1 is 1. Algebraic multiplicity of eigenvalue 1 is 2, but geometric multiplicity of eigenvalue 1 is 1. Therefore, AM is not equal to GM. Therefore, the matrix is not diagonalizable. Understood? The matrix is not diagonalizable. In this way, we can identify whether the matrix is diagonalizable or not. Understood? AM and GM of each eigenvalue coincides, we can conclude that the matrix is diagonalizable. Otherwise, the matrix is not diagonalizable. Understood? Thank you.